So for this one, I'm just going to also graph it simultaneously in Desmos at the same time, because finding the intersection points for this one is actually like really tricky. So I'll show you what's going on here. So to start off with, we want to find the area of the region that's inside this circle, r is equal to cos x, and inside this rose, r is equal to cos 2 theta. Now, one thing we really need to be careful about is that the angles that correspond to the different parts of this rose aren't as intuitive as you'd think. So, for instance, like we know we start here and then go down this way. And so, even though we think here like, oh, okay, like if this is pi over 3, then this part of the rose should be for like angles slightly greater than pi over 3. No, for angles slightly greater than pi over 3, your curve goes down this way. So this one is tricky, but I'll walk us through it, and it's maybe the kind of thing I'll go over again in class a little bit, just kind of pointing things out. But anyways, let's find our points of intersection the usual way and see like what we can do with that. Maybe I'll just kind of shrink that for now, but these are going to be important in a sec. Okay, so intersection here. If we start off with just saying cos theta is equal to cos 2 theta, so like that type A intersection, what we get is, if we rearrange things, we can say this is the same as cos 2 theta minus cos theta is equal to 0. We can write that as 2 cos squared theta minus 1 minus cos theta is equal to 0. And I'll factor this. It turns out as 2 cos theta plus 1 and cos theta minus 1 is equal to 0. Then, from this first factor, we get the solutions. Cos theta is equal to 2 pi over 3. Or no, not cos theta. Theta is equal to 2 pi over 3. Okay, yeah, because here, so cos theta is equal to negative 1/2. So theta is equal to 2 pi over 3, or theta is equal to 4 pi over 3. But if we look at the points corresponding to that, the polar coordinates are negative 1/2, 2 pi over 3, which we know is the same as pi, either negative pi over 3 or 5 pi over 3, right? It's because we can just keep adding or subtracting pi. And same with this other one. The point negative pi over 2, pi over 3, 4 pi over 3 is the same thing as the point 1/2 pi over 3 in terms of like where it's located on the plane, but we need to remember that it corresponds to like different parts of the curve. And so when it comes to calculating this area, we've got a bunch of different options, and I'm going to do it in a way that might seem kind of counterintuitive, but I think is the easiest to calculate in terms of the angles. So to start off with, okay, so I tried doing it a different way before, but I actually don't think it's makes a lot of sense, so I'll erase that. Okay, so the whole area that we want, I'm going to kind of break up into a few different chunks and then look at them separately. So, 1 second. So the total area that we want, we're going to call A1, A2, A3, A4, and all together we can say that A is equal to the sum of those. But A1 is equal to A4 and A2 is equal to A3, so we can just say that it's 2A2 plus, I'm going to go 2A4. So those are the ones that we'll be calculating. A2 and A4. Now A2, that's one that's not too bad. A4 is a little trickier, but I'll go through it. Or, oh, we might even break it up further. Okay, we'll see. Yeah. Okay, so the point is, for A2, this area starts when theta is equal to 0 and r is equal to 1. So I'll label that down here as well. And then it keeps going, and it's only defined by the petal curve, or the rows. And then we hit 0. Well, when do we hit 0? Let's see. So cos 2 theta is equal to 0 when 2 theta is equal to pi over 2, or 3 pi over 2, or 5 pi over 2, so on, which means that theta is equal to pi over 4, or 3 pi over 4, and so on. So here, the one that we're going to be using is pi over 4. That's what defines this area. And to show you that more exactly, here on this Desmos graph, we can see that if I have this sketch only the circle and the petal, but the petal is limited to values of theta between 0 and pi over 4, we only get this piece of the graph, which is perfect. We only, like, that shows us that means we got like the right area idea. Boop, 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 boop. There we go. So here, this graph is this limited to that. So, okay, that's good. That means we have the right, I'll put that in purple too. That means we can say for sure this is like the range of values that we're looking at. And indeed, if we think about the whole idea of like drawing the rays, as we leave the origin, we can see that those are exactly the angles that define that area. So as a result, we can say that for sure A2 is equal to 1/2 the area from 0 to pi over 4 of, so the rows is the cos 2 theta, so we take cos squared 2 theta because we have to square for these areas, d theta. Cool. So whatever that works out to be, that's what we're dealing with. Then for A4, okay, you know what? Yeah, I'm going to be annoying here. I'm sorry. I'm going to actually divide it up differently. Actually, no, sorry. I didn't bring lunch today. I should have. That's what I think happened here. Anyways, okay, let's find our intersections. Maybe I'll resize this and crop it. Okay, so this A4, we can see that for half of it, we're actually looking at the area inside the circle, and then for the other half, we're actually looking at the area inside the petal. So here, if we draw this ray, we can see on this side, this is just area inside the circle. And then on the other side of that, we only have area inside the petal. And we know that this intersection point from our calculations above happens when theta is equal to 2 pi over 3. Okay, cool. So then that means that what we have to do for A4, if we break it up into two pieces, let's say this is B1 and B2. There might be an easier way to do all of this. I'll upload this way and then I'll see if I can think about it more. Okay, so B2, we need to know the bounds. So it starts at 2 pi over 3. When does it end? It ends when cos of 2 theta is equal to 0. And we saw that the second version, like the second angle where we get that, is theta is equal to 3 pi over 4. And indeed, if we move back to the full graph and we think about the angles corresponding to the polar curve, so we're at 0, pi over 4, pi over 2, 2 pi over 3, 3 pi over 4. That's the second time we go through that. So here, tracing curve to check. Okay, so that means then this little area B2 we can say is 2 pi over 3 to 3 pi over 4. And then it's again just cos squared 2 theta d theta. Oh, and the 1/2 in front. And so this one I've also sketched out only that part. And you can see that is indeed what we're dealing with there. Okay, cool. So that's our B2. But then for B1, you've got to figure out what that is. So this is our B1. Let's see, so cos of theta, that's the circle that we're dealing with. When is that equal to 0? Well, for angles like pi over 2. So you know what we can do actually is let's say in this Desmos, we're looking at theta between pi over 2, and then we know that they intersected at 2 pi over 3. And that's exactly what we want. Awesome. Okay, cool. So this first intersection happens at 0. R is equal to 0 at theta is equal to pi over 2. And then intersect at theta is equal to 2 pi over 3. And indeed, we can... Actually, yeah, I'll take a screenshot of both of these and add them with like the limited graphs to kind of show what's going on. I really can't recommend Desmos for this kind of thing highly enough, just to make sure that you've got the right bounds of integration, because otherwise it gets messy. There we go. So that means then that our area B1 is 1/2 that integral from pi over 2 to 2 pi over 3 of cos squared theta d theta. And we had initially been trying to find A4. A4 is equal to B1 plus B2. So total area is equal to, let's see, so we know it's 2A1, oh no, 2A2 plus A4. Okay, 2A2 plus 2A4. So that's 2. What was our integral for A2? Oh, it's right up there. Okay. So 2 times 1/2 integral from 0 to pi over 4 cos squared 2 theta d theta plus 2, and then a4 we know is those two integrals, so we can add those together as well. So we go from 2 pi over 3 to 3 pi over 4 cos squared 2 theta d theta plus 1/2 pi over 2 pi over 3 cos squared just theta, not 2 theta d theta. So whatever that adds up to, that's our area. I'm going to see if I can find another way to do it, but for now I'll just upload it like this. And yeah, and I'll go over this on Monday a little bit too, maybe before we start chapter 5. The main thing I really want to emphasize is that this part here is cos theta, for theta from pi over 2 to 2 pi over 3. And then this here, this part of the area is cos 2 theta, for theta from 2 pi over 3 to 3 pi over 4. And we need to realize that, like, yeah, that's exactly what the area is. We never have an inside minus outside as just those guys. So I would say this kind of thing is more difficult than area between curves for sure, because it's hard to kind of wrap your brain around it, but that's it. Okay, well, hopefully this helps. Have a good weekend. Bye.